Okay, today's lesson is Variables and Expression, lesson 1.2. We're going to start thinking about words that we use to suggest the following operation. So we'll fill these in as we go. So here are some of the words that we use to describe addition. We could use the word plus, sum, or in a phrase, the sum of, increase, or increased by, more than. And of course, added to. For subtraction, we could use some of the words like minus, the difference of, decrease, fewer than, less than, or even subtracted from. Okay? For multiplication, words that we use are phrases times, if we take one number times another number. Product also indicates that we want multiplication. Of course, multiplied by, and also a word that means multiplication is of. We used it today in our warm-up when we took 70% of 150. That indicated that we multiplied. For division, we have the obvious one of divided by. We could also use the word quotient, the quotient of, or we could use per, as indicated in a lot of the rates, like miles per hour, and that per means to divide miles by the hours. Okay, in the very first example that we're going to do, we're going to evaluate an expression if x is equal to 5 and y is equal to 8. The method we will be using is called substitution. So we will take the numerical value that is equal to x and substitute it into the expression to solve or get a value of it, to evaluate it. So for A, I first want to rewrite the expression with the numbers substituted in. So wherever I see an x, I put a 5. Wherever I see a y, I put an 8. And then I will just simply add them together to get 13. All right? The same thing's going to be true for part B. Sometimes it's kind of handy because when I see this 4 right next to this x and this 7 right next to this y, I'm going to substitute it in, but I don't want them to look like the number 45 or 78. So I might need to use some parentheses because a number next to a letter like that or variable indicates multiplication. So I need to show with my notation that I am multiplying these as I substitute them in so that I don't lose that. Now, what are some ways to show multiplication? I'm using parentheses. Is that the only way that I can show that? So one thing to be careful of is that we don't use a time sign to show multiplication because that time sign would look like a variable. You could, however, if you want to, show with a dot multiplication, so 4 times 5 plus 7 times 8. That would work as well when you use substitution. So then we'll do our order of operations and we'll multiply first, so we'll get 20. And then 7 times 8 is 56. And when we add them together, we get 76. Okay? So for part C, we want to substitute in, again, I'm comfortable with the parentheses, so I will use 8 times the 5, which is the x, put the fraction bar, and substitute in the 8. When we do these types of problems in order of operation, we know that we want to simplify the numerator and then divide last. So 40 divided by 8 will equal 5. Okay, in our next example, we are going to write a variable expression for each phrase. So when we do this, we want to look at it and then try to pick out some of those clue words that we talked about that indicate operations. And then we also have to be very, very careful about the commutative property, because we know that addition is commutative but subtraction is not. Multiplication is commutative but division is not. So sometimes it's just good to follow it along left to right, but other times we have to really think about what that means as to which expression or which number or variable to put first. For the variable, whenever they use the word a number, you can use whatever variable you want. Sometimes I use n, sometimes I use x. You can use the first letter of your name. The actual letter will not matter at this point. So writing the variable expression, the sum of a number and 9. So we can look at the clue word sum, which tells us addition. Here's our variable, and then here's the other number. So n plus 9 would show the sum of a number and 9. Looking at B, 21 fewer than a number. So here's the words that or the phrase that will let us know the operation. So we know that fewer than means subtraction, and if we see and read it left to right, we have 21 minus n. However, the way the phrase fewer than indicates is that 21 is smaller than the number, is fewer than a number. So the number's the bigger one, right? The number's the first one, I should say. The number is the first one. So we have to make sure, because it's not commutative, that we are subtracting the 21 from the variable. So n minus 21. So please, make a note of that one, that whenever the words fewer than are in your statement or phrase, that when you write the expression, it might not just be left to right. For C, the product of 6 and a number. Product means multiplication. So I have 6 and a number. So I could just write 6n. Of course, I could use parentheses. I could use dot multiplication, however I want to do it. For part D, the quotient of 48 and a number. Quotient means division. So again, I could do 48 divided by n, or I could do 48 divided by n. I could write it a couple different ways. And then finally, E, 1/3 of a number. So this is telling me multiplication, and what I'm multiplying to the variable is 1/3. So I literally would write the fraction. 1/3 n indicates that. Okay, now we're going to watch an example of a more complicated one.
How do parentheses help us write algebraic expressions so we are clear on what they mean? For example, how do we write the algebraic expression 3 less than a number, comma, times 20? In this lesson, you will learn how to write and read algebraic expressions by using parentheses. Let's review. An algebraic expression contains at least one variable and at least one operation. 25 minus 3 times x minus 2 is an algebraic expression. Remember, there are alternative notations to show multiplication without using the sign x. There are 3 different ways multiplication can be shown in an algebraic expression. 2 dot x is the same thing as 2 times x. 2 parentheses x parentheses is the same thing as 2 times the quantity of x. And the most familiar is 2 right next to x, which also indicates 2 times x. Division can be shown in 2 ways as well. We have 4 divided by x, or the more frequently seen notation, 4 over x. That also indicates division, 4 divided by x. A common mistake is forgetting to use parentheses correctly to create an expression within an expression. Okay, we see that we have an expression listed on your screen. The expression is the one from the very first slide. 3 less than a number, comma, times 20. What you see first is that there is a comma in this particular expression. That comma means that everything before is a separate expression. It's going to be done first. It's kind of like a reverse order of operations. So, I know that I need to put parentheses around 3 less than a number. So if I want to write 3 less than a number in algebraic notation, I'm going to write x minus 3 because it's less than a number. All right, and when I do that, I know I'm going to need to enclose that in parentheses. Now I'm going to take this whole expression, parentheses, x minus 3, parentheses, and I'm going to need to multiply that times 20. Okay, so now I have part of the expression written in algebraic form and part of the expression written in word form. What I can do is now take times 20 and I'm going to just change that to 20 and I'm going to multiply 20 times the quantity of x minus 3. Since 20 is being multiplied, I can use it at either the beginning or at the end, but you're more likely to see it located in the beginning. So these are two factors. I know that I'm going to get a product of these two factors. My expression is going to be the product of 20 times the quantity of x minus 3. In this lesson, you have learned how to write and read algebraic expressions by using parentheses.